Yeah, I'd love to be able to sort of share it with Kwesi if you wanted it.
Okay.
Great. So I put on these questions. What is architecture and design? Is it interior design different from architecture? How long does it take to become an architect? What schools to apply for and what do they need? How do I know if I want to commit to architecture? What are the summer programs out there? How to design resiliently to protect from fire and earthquakes. We just had crazy fires. What is design thinking? What is the daily life of an architect? Example design process. What was my journey in particular? So these are just sample questions. I thought I would throw them out. You tell me if which ones are important for you, or do they cover what you would like? Which ones, stand out the most to you, or others that are not here?
Okay, I think the first one, like I think I'd want overview of what it is first.
Yeah,
Okay.
which is
And then
yeah.
yeah. And maybe something about the design process because yeah, I'm curious about like how you design stuff.
Sure. And you know what? It's one and the same thing. Okay, so those are the two important ones, and we can just go from there.
Yeah.
All right. So, architecture is really about designing the built environment. Now, you can dissect the built environment into, um, everything that you see in a skyline, right? Um, Architecture in particular is about the designing of the building. When you do the designing of the spaces between buildings, at a small scale, that is called urban design. When you do it at a city scale, and you decide where buildings go and what their uses would be, that's called master planning. But when you go to architecture school, they will they teach you through different semester programs how all of these are interconnected because the how a building is designed, especially a building is designed, has a function to it, and that function then operates within a larger context of the city. And so architecture really is simply is the art and science of putting a building together for a particular function, for a set of people, most importantly, for a set of people to use. And there are so many different ways of doing it. There are so many different kinds of architecture that we see historically. We feel different in different spaces. There's the psychology of space. There is form follows function. There is, different periods. The current construction technology, the software technology that we use for development design influences what we build, how we build, and how we design. So what is architecture and design? Very simply, again, it's the art and science of putting a building together for people to come together to perform a particular function or to come together for a particular purpose. So that is what is architecture and design. How do we do that? We do that really through a design thinking process. And you can use that design thinking process to solve any problem. And so what is design thinking as a process? So you start with sort of empathizing and understand the users and their needs. So for example, let's take something as simple as the your house, right? Or
Okay.
the apartment building that you might be in, or the school that you go to, right? Each one of these has completely different characteristics, right? And
Yeah.
so you first understand who is going to use this, what are their needs, and you also try and understand where are we putting this and what is the site and what is the context. Are we on a hilly side and are we in a cold climate or are we in a dry climate? Are we next to the ocean? Anything you build in the desert in Dubai will be very different from what you build in California, will be different what you build sort of up in the mountains in Utah where it snows, or for that matter, upstate New York, very different climatic conditions. So, how the building comes together for its users changes based on what the site and its context is as well, including climate. Then we sort of, you know, ideate and we generate a wide range of possible solutions without judgment. We just throw them out there. All possibilities might exist. Let's see what sticks. And we synthesize all of the information that we've sort of gathered through the process of empathizing and ideating to basically define what is the problem statement? Like, what is it that we're trying to solve here by understanding our site and its context and understanding what is the need of the users? And what are the other criteria, for example, that the building code or the city and the agency that will permit it, what are their criteria as well? So we're basically bringing all the information and understanding and defining the problem. And as we ideas come up, we basically test those ideas, and we test those ideas by sketching them, by making models of them, just like the model that you're making, then and then building prototypes in terms of 3D models, in terms of physical models, just like you're making, and then go back and see, is it fitting, which one of these is fitting and answering or resolving the problem, um, and go back to the users and ask them the same question as well. So the process of architecture and design comes from a design thinking process, and these are the steps that take you. And as you are ideating, testing, and prototyping, it's an iterative process. You might do multiple versions. You might go back to your user. You might take a look at what the issues might be and see, how do I need to change it? So it's an iterative process. I think just like you've just made that beautiful um, sphere out of a pentagonal shape, if you pentagons, correct?
Yeah.
Pentagonal shape, which is, similar to the idea of a geodesic dome, which is made with by Buckminster Fuller with sort of triangles. Do you know who Buckminster Fuller is?
No, I don't.
Okay, write him down. So Buckminster Fuller was an architect in Canada. I don't even know if he was actually a licensed architect. He would make spheres as building types using triangular parts. And if you take a pentagon and you draw its center, you can actually divide it into multiple triangles. And a triangle is the strongest element. You can actually make a table out of a triangle as well, right? So now, how do we use this idea, for example, in a design process? And so again, this is another diagram that's basically showing the same thing: empathize, define, ideate, prototype, and test. And as you empathize, which is you understand what the problem is, the context is, the site is, you're defining it. And then you're creating your idea spark. That's something that's original, that comes out of you. Sometimes you do case studies to see how similar people used, had addressed the same problem and how did they really solve it completely. And then you prototype and you test and you keep iterating it, right? But as you do that process of ideating, prototyping, and testing, especially the prototyping and testing, in a 4-step process. And so the first step is called sort of concept design, which blends into schematic design, and then design development, which is DD, and then construction documents, which is actually showing, what you have thought into a series of documents that a contractor or a builder can take to build. And then finally, assisting in the construction process called construction administration. So architecture is the process of basically 1, 2, 3, 4. During this phase is when you are doing all of this. And before you get to schematic design, you're understanding what the problem is. So a large chunk of your ideas really are coming at this phase, the most valuable phase of the process where, you are understanding, defining the problem, ideating, iterating, going back to your users. And at some point, the users and you will come to an agreement as to know which direction you want to go in. So you start to develop that further into design development. And then you develop it even further more so that now you can prepare documents so it can be built by the builders to implement it. And then here you are in the process helping to figure out how to and answer questions to the builder. That's construction administration. So um does that process explain itself before I go into a case study?
Yeah, I think so. Yeah. So like, so
Yeah,
uh you get ideas and you test them until you like get something that you and the people like.
exactly. You and the users like, whether it's a school, whether it's a shop, whether it's a hair salon, whether it's your home, whatever it might be.
Okay.
Great. You're absolutely right. So that's why we call it an iterative process, right? Okay. So you go to Harvard Westlake, you have a beautiful school, you have two campuses, lower campus, upper campus. Um, we can look at multiple different case studies here as to how you would use design thinking as a process. What I will do is I'll quickly run through this. There's a case study I have for designing a school. Then I have a case study that also shows how I built a duplex. This is for two families, one on top of each other. Um, uh, which one do you prefer? A duplex,
Uh,
just smaller in scale, so it's like one apartment over another apartment, or a school?
uh, maybe the duplex.
Okay, let's go to the duplex. Absolutely.
Yeah, if we have time, maybe we can go to the school after.
Absolutely, absolutely. Okay. So I got a call from a client. This is a physical project. It's going to get built soon. It's already permitted. It's a site in Santa Monica. It's sort of a regular size lot. Most lots or most properties are about 5,000 square feet. This is about 120 feet by 50 feet, so a little bit more than 5,000 square feet, closer to 7,500. And it's on a corner site in the city of Santa Monica. It already has sort of an existing building that has four apartments in it. There were three brothers. They came together and they said, well, you know what? There's space at the back, and the city is allowing us to build accessory dwelling units. What if we built two ADUs, which the city allows, here at the back? How would we do it? So they ended up selecting me as the architect. So I first, they basically said, okay, well, Pooja, what can we build there? So I did some work and I looked at what the ADU laws were that the city has put together and the state has put together. And I said, well, you can build a maximum of 1,000 square feet of an ADU, and you can do two ADUs. You can do them in in an area on this site such that the boundary of the ADU can be here. This is the entire area you can build it. So first figured out the rules, right? So from here to here, you need to leave 6 feet. From the property line at the back, you need to leave 4 feet each. And I said, okay. And then I said, there's a height limit to it. You can't go more than 24 feet in height. So where do you think we should put these? So I did some internal layouts and I came up with an internal layout, or a few different internal layouts, and I came up with four ways of doing this. Their goal was that we want to be able to rent these to the people who to the office to to the folks who are walking distance office goers, because this is sort of like in the office part of Santa Monica, and they wanted people to be, most people want to now not get into their cars and drive for very long distances. So they thought, all right, we can you know put these two apartments one on top of each other, or two apartments, and figure out how to rent them out. Okay, so here comes me, and I said, well, there's a couple of ways of doing it. Um, Light blue is 180U, so 1,000 square foot, three bedroom, two bath, because they wanted to maximize the number of bedrooms. The second light blue is exactly the same as well. And I said, you can organize them. And this is the existing building. And, I made these sketches first by hand. I did the layouts for each one of these four different ways of doing it. So I had A, B, C, and D ways of organizing it. The white is the existing building. The light blue and the dark blue are showing the two 1,000 square feet, three bedroom, two bath each apartments. They're tiny, but they wanted to maximize the number of units. So I'm going with what my user or my client wants. So I came up with the idea of, well, what if I have them side by side and they were two-story townhouses, right? What if I did the same thing, but the parking at the back that I cannot touch and the building at the back I cannot touch? What if I did it in such a manner that I covered that, and now I get more open space and more balcony space, if you will? Different configuration, one and two, side by side, so different from that. But what if I just stacked them one on top of each other and I had the access from the street, because I have one street here and another here? Or what if I did them one on top of each other, but the access came from the space between the existing building and the proposed building? And so the client ended up saying, well, we really like this. And I said, why do you like that? And I also presented pros and cons as to why. So the pros and cons of why this is nice is that you come in to this space, into this apartment, and it feels like, you have your own entrance, and that you're able to use the courtyard space between this building and this building. And you have a separate entrance that takes you up, in, and inside. So that was my first step of the process, was understanding the rules, understanding the client's requirements. Their goal here was two apartments, three bedroom, two baths, to be able to, put it on rent in the most efficient way possible, but also in a way that is has privacy, and has privacy, as well as feels like each one had sort of a different characteristics, and was the most efficient as well. So, created sketches, used three-dimensional software. This is done in SketchUp, and then showed them this, as well as plan layouts of how the three-bedroom and two-bath would work. So, for example, you see it started off with a sketch like this, and it took multiple sketches. And then what would that look like? And it sort of started with a sketch like that. And so what does the plan look like? So if you enter in, that's the L-shaped kitchen, that's the dining area, that's where the couch would be, that's the TV. You'd enter in, you'd have one bedroom here with a bathroom. You can enter directly from here. You have a small bedroom with another bathroom. And then you could go another one here and another bathroom and bedroom. And so, you sort of like, you're constantly sketching both in 2D and 3D to understand what that process really looks like. And ultimately, the client did end up liking this one, even though we made floor plan layouts, that's called a floor plan layout, right? And you're sort of seeing that's the existing building, and that we're creating sort of a courtyard space between the existing and what we call as proposed. The parking remains untouched. You can enter in straight into this. You can take the stair up and go into that. And so, the ideas come from inside you as to how, and you try and test them, and you try and see which ones fit the bill, right? So it's an iterative process, and we had four different ways of doing it. The client ultimately chose that option. So then we started go back into, okay, well, how does that start to look from a three-dimensional perspective, both on the inside and the outside? And so you can see we decided that because it's on the street, that we wanted to give a little bit of privacy to the folks who were entering into these apartments, right? And so we said, okay, from here you have a little gate, you can go in and you can enter in, and it feels like it's your own house, even though it's an apartment. Similarly, you can enter in from here and that go here and then go behind the stair, and once you're past this screen, or a vertical trellis is what we call it, and you climb the stairs, you feel like these are your stairs, even though they're stairs that are exterior to the to the building. And then you can enter in. So and this one has its own balcony. You can see the balcony that's facing the courtyard, which is between the two buildings. So, and how to best organize the space between the two buildings was equally important to us, so that we're sort of creating a nice space for both the existing units as a shared space, as well as for the new units that are coming in, and that the people can come in and come together as a community as well. Even though they're shared living. In the existing building, there are four small one bedroom, one baths. So it's tight, but there's sort of micro units, if you will. And so you can say, we did it. Here's one way of doing it. Here's another way of doing it. And here's another way of doing it. Although this way is similar to this way, it's just a color difference. And ultimately the plan remains the same, but you can see it becomes different as well. Each one of these came from different ideas. So, for example, this is in the city of Santa Monica. The Pacific Palisades, or if you go down to, have you been to Santa Monica?
A couple times. Yeah.
Couple of times. So there are the bluffs on the ocean, and you can see the bluffs on the ocean, and as the water sort of comes down it, they sort of create these interesting textures. So this was in Santa Monica, so we sort of created a texture of that variety. We made sure that this was sort of a screen here, because we wanted to make sure that there was privacy for the person who was going in. And so, we thought, okay, well, what if we take wood and bend it, with a steam building process, which is exactly used by the same people who make boats. And we bend it, and it sort of like looks like a curtain that's frozen. If you were entering past a curtain, you would sort of move your hand that way. So it's like a little frozen opening, if you will. And so, everything we try and do, at least in my office and my practice and the way I think about it, comes from a sense of purpose. So we call it purposeful design. And so ultimately, the client, and we did multiple iterations and multiple studies, and ultimately for that same floor plan, because you can have the same floor plan layout and you could do it this way, or you could do it that way. And if you change the color, you can see, and change the material, you can see how it's done as well here. But the floor plan layout remains exactly the same. So so the client ultimately chose with that as a model. And so this was during that initial schematic design process. Then what ends up happening is we actually start to create construction documents. What is the wall type? Does it have enough insulation in it? What is our building envelope going to be? So what that means to say, what are these walls made up of? How did your building envelope is basically all the kit of parts that make or protect the building from the elements, from the natural elements, right? And there are energy codes in place, and it's called the California Building Code, that will basically say, okay, well, you need to make sure you're designing in a way, and you are specifying your wall types in a way that your building envelope is allowing for energy to sort of to control the humidity and the temperature from the to be controlled both inside as well as the outside. I think we have someone new. I just saw that we have another participant. Let's take a look who that is. And that is Eric. Hi, Eric. Can you hear us?
Hi. Sorry, I'm in college right now. I saw Mr. France sent this uh,
Okay.
talking about. We
Uh,
met last year in
yeah,
class.
we've lost him. Well, Eric, welcome. And you're welcome to switch your phone off if you can't talk. But please interrupt me if there are questions. I'm basically answering Kai's questions about what is architecture and design, and walked him through a case study for an apartment building I designed as an example of a design thinking process of arriving at a building. And now we're talking about, after we design, exactly what sort of like form and shape this takes by sketches and 3D models and physical models, then we like start to think about what are the kit of parts that actually make this. How do we make it? So that's sort of where we are, Eric. And if you want, please interrupt me. I heard you say that you are in college right now. That's amazing. And you're saying that you met me last year. So what would love to hear what you're doing in college, and so glad to hear that you're participating from college and you're not at Howard Westlake anymore.
Yeah, I'm considering just pursuing a career in civil engineering and structural engineering.
Yeah.
So trying to understand more of the architectural side of things and
Yeah.
knowing all of that stuff, I think is really important. Sorry
Of
if you
course.
can't hear me right now. I'm just walking back to my dorm right now.
Okay, great. Which college are you at?
I'm at Brown right now.
Oh, phenomenal. Very good. Fantastic. And you're a freshman?
Yes, freshman.
Oh, that's phenomenal. Okay. And you have my email address as well, Eric. So, feel free to email me. I can put you in touch with a lovely structural engineer who is also very, very giving, and she's quite phenomenal. She teaches as well structural engineering. So if you're interested in both structural engineering, civil engineering, happy to connect you with folks in Los Angeles.
Oh, awesome. Yeah, I'll definitely reach out for that.
Okay.
Thank you
Okay.
so much.
Of course. Okay, so Kai, we're talking about the building envelope. Now, the building envelope also needs to stand. So, from a structural design perspective, we need to make sure that we have enough what's called load-bearing capacity of these walls, and we live in earthquake country. And so we want that our building elements should move together when the earth moves, which includes the foundation on which the building is created, as well as the walls, and all the walls and the roof elements move together with the foundation of the building. And we also want to make sure that when the building moves, everything moves with the earth, because if it didn't, it would basically, that's where sort of collapse happens. And so, Eric, in terms of structural design, California is definitely earthquake country. Places like Japan and Taiwan are earthquake country as well. And so we really take a look at sort of what's called shear walls and seismic forces to design, to withstand certain magnitude of earthquakes as well. If you lived in sort of New Orleans area, or you lived where sort of the Gulf of now Mexico slash Gulf of America, which the name is changing, I heard. If that, if you were living there, you would then try and withstand for water, for cyclones, for floods, and things like that. So your structural design elements change based on the climatic conditions sort of where you're in as well. And so your building envelope needs to be designed, which is your roof, your walls, and as well as your foundation slab has to be designed that it can control the temperature that you're going to have inside. And so that every time there's a fluctuation of the temperature during the day or in the evening, or if there is rain or it's too hot, you have a certain temperature control that can happen naturally inside the building because of the elements. And that, that it's not like whatever's happening in outside is happening inside. And that if you were to bring in air conditioning systems to control the temperature, that you were able to control them in a way that it doesn't use that much energy to maintain that temperature, if you will. You decide how big your doors are going to be, how big your windows are going to be. You want to be able to sort of look in and out of your rooms, because we as human beings require a certain amount of daylight. We require a certain amount of fresh air, and the building code makes sure that we're providing that for certain rooms. We also make sure that from a fire perspective, any room that is a bedroom that you sleep in, has certain code requirements as well, so that in case of a fire, the window sill has to be a certain category, not too low, not too high, not too low so you don't fall off it when you open it, and not too high that if you need to, like, if fire if the fire department wanted to access it, then they can sort of cross over that windowsill and be able to jump in to help save you, if you will. And so that is one case study for a project. And you think about all of these elements. You work with a structural designer, you work with a mechanical engineer, you work with a structural engineer, you work with a civil engineer. And so, the architect becomes a little bit of a mastermind. Once in a concept or an idea has taken shape and your client has agreed to it, your users have agreed to it, then you bring in, your structural engineer who will help you make sure that the building stands erectly. You make sure that you're working with your plumbing engineer so that you're routing all of your water elements, if you will, as well as waste elements inside your walls. You make sure that you're working with your mechanical engineer, or your HVAC engineer, basically heating, ventilation, and air conditioning, so that you are installing the right units, the right ducts, and you have a place for all of that. You work with your civil engineer to make sure water flows away from the building, and you work with your landscape architect to make sure that you're using, the right amount of green elements as well to make this pleasant. So in some way, and then you finally bring in you finally create construction documents, and those construction documents are then sent out to bid to different contractors. The client decides which contractor gets the job based on their response of their bid, the estimate that they've created as well. Your drawings that you produce are done in such a way that the contractor can estimate quantities and can understand what is what, how far apart it is, how is it all made of. And so you produce drawings in two-dimensional and three-dimensional format, plan format, and section and elevation format, and just not views, so that the contractor can then use multiple subcontractors who specialize. Each subcontractor specializes in something different. So if you're building the building in wood, you want to be able to send it to the framer. Once the framer finishes, you get another subcontractor who applies drywall. Then you have another who's the tiler, who will tile, which is a moisture-resistant barrier in bathrooms. So on and so forth. And then you're answering questions during construction for the contractor once he starts construction as well. So that, in a short, was what is architecture. And there was a lot of words there, and I was wondering if these images did any justice to all of that stuff that I said, Guy.
Yeah, I think it's interesting how there's like so many things you have to think of and how you can make it like fit with what the people want. And I thought it was interesting how, like you said, how like the trellis, it like provides privacy, but it also gives the sense of like the person being like in their home, even though it's technically outside. And I think, yeah, those aspects of designing like things, I think that's interesting how much thought goes into it.
Yeah, absolutely. And that's where there's a form follows function. If you understand that concept, then there's a form follows purpose. And then, each one of these also results in how you feel psychologically in a space. Colors evoke emotions, materials coming together evoke emotions. So there's a psychology of space as well. And how do you make, something that is, you know, there's just two apartments here, right? And they're for rent. It's not high-end design. It's not somewhere up in Bel Air or possibly, in a very rich area. This is sort of on the flats and on the ground. You want to make sure that you're making extraordinary spaces out of just ordinary materials, if you will. And so that's where the creative aspect comes in. The more scientific aspect of it comes in when you are working with your engineering consultants as you think through that process. The psychology of it and your empathy of it comes from you understanding the needs of someone else and making sure that you're designing for someone else. Your financial, mathematical brain also comes in because you have to make sure that this is done within the client's budget and you have to value engineer or reduce the cost. So actually, this is not how it ended up being. That steam bending process was expensive. So we actually created a different screen. We used a product called New Tech Wood and we created a vertical trellis that had an interesting pattern that still allowed for that privacy, still allowed for a screening away from sort of the street, and still gave a sense of purpose and identity to the building. And we did it without a steam building process, with a modular process. So this did get value engineered so we could fit into budget. And so you have to be nimble. You have to be flexible as well. All that goes into it. So in some way, an architect is a bit of a mastermind. And the design thinking process is interesting because you can use that design thinking process to do anything. You can use that design thinking process to, and I have a slide here where I say, well, how do you use a design thinking process to design think your own future? And so I created this as to like, well, if I have to empathize and define, then let me try and understand what my passions, strengths, and experiences are. What are the insights that I can get from my friends, family, and teachers? What are my goals, my aspirations, and what does success look like for me, right? Or for you. And you can explore your path to achieve your goals. And you do case studies just like you're doing. You're both attending right now. You're listening to those in the field to understand how they ended up. And then you're doing this exploration process and saying, well, what if I became an architect? What does that mean? So you're doing that right now. You're exploring that. You take courses, you volunteer, or you do internships, you take summer programs. And then you reflect, gather feedback, and you adjust your path. And so you're using that same, idea of design thinking towards multiple things. You can use that towards solving any problem, if you will. It's a question of how do you interpret the words, or the process, if you will, towards any solution. And we use this for any building type for that matter, or for any problem solving. Should we go back to our questions?
Yeah, sure.
Okay. And Eric, do you have any questions?
Yeah, I guess, do you foresee that the architectural design will shift after the like recent fires and stuff? Do you think codes will change, or do you think? Okay, I'm sorry if you covered that already in the first half.
No,
I just
no, this is a very relevant question. Kai is a freshman. You are a freshman in college. You're 4 years his senior. So, you both bringing in different aspects to this conversation. So, Very relevant question, Eric, and very timely question as well. So, how do we design resiliently to protect from the fire, to protect from earthquakes, to protect from cyclones and stuff like that? Why did the Eaton fires and Palisades fire create that much destruction? How can we prevent that from happening in the future? Will the building codes change? How do we really design so that, that if the Palisades and the Eaton and the Altadena community were to get rebuilt again, so that it never happens again, even with those kind of awful winds, right? There's multiple ways to answer this question. There is an ecological standpoint, a macro standpoint as well. So let's talk about the macro standpoint, or the ecology of a place and the larger topography of a place, and how that influences, and the good design and planning of that influences how the fire can be stopped. So that's one aspect of it. Then if you go down, you can zoom down into to the process of what does the individual structure look like, and what do, the schools, the churches, the businesses and the homes that are lost, and the total loss of community. You come down to the individual home or the individual business standalone structure. What can we do that can be designed resiliently as well? And so there is a collective, you have to think through this problem collectively. So let's try and understand that from an ecology, from a macro Google Earth standpoint. We had in the last couple of years the really, really, really wet winters that created the super bloom and the amount of greenery we had. The kind of stuff that grows on our hills has a lot of oil in it, has a lot, because it has to survive, because we're sort of in a desert climate, if you will. That, if burnt, not controlled, not maintained, not cut down, and allowed to grow, is fuel. If you have a little bit of fuel and you have a little spark and you have a lot of wind, what happens? That's what happened, unfortunately. Now we have strong winds blowing through a big hill down into the ocean, right? So that's your climatic conditions as well, right? You've got low pressure and high pressure systems that are created as well. So from an ecological standpoint, what the city, from a master planning perspective, needs to really control where we have brush and where we don't. And how do we control it? This is not high fire season for Los Angeles and for Southern California. That's more in the summer. We achieved this year, because of climate change and stuff like that, we achieved 1/6 of an inch of rain rather than the 6 inches of rain we should have received. So we had like this perfect, terrible combination of 2 years of excess amount of moisture, too much growth, waiting for the rain to come, didn't. It's not wet season. It's not maintained because nobody expected, this to be fire season. And we had the awful disaster we did. So we don't have a choice as a community, as an agency, as those who are master planners, those who are actually maintaining the building, maintaining sort of the overall city. We don't have a choice but to be able to maintain brush clearance throughout the year. So now there's that topography, and we need certain distances away of that kind of brush so that it cannot catch fire, and that if it, and that, so there's going to be some level of I think landscape planning and topographical planning that will need to come into play along with its maintenance that will allow this never to happen again, right? So that's one. So that's master planning level, landscape level. There's also civil engineering associated to it. You had so many winds that you had these poles that have power poles that were catching fire as well, right? So we need to have no choice but to underground all of our power poles. That's one of the things that's going to happen, right? So that's again at a level of the agency, at the level of planning utilities. So when you're planning, you're not just deciding where buildings go, where homes go, where offices go, where markets go, but where do our infrastructure go? How does that infrastructure react to worst case scenarios as well? So that again, so you've got utility planning right there. Now let's get down to the individual structure and the microcosm of when you get down to that level, you're basically talking about an individual home because that's what we as people experience. Then you have a collection where at the market, businesses where people come and collect. So let's talk about just a structure like a home. So, I'm just going to sketch and draw right here and talk about how that can change its design as well. So, first of all, let's talk about either of the, whether it was Altadena or whether it was the Palisades. The issue we have is that it was a collection of buildings from the 1950s, 1970s, from even way before that are not up to current code. So even if you have a current code, California Building Code basically says that you are designing to resist 1 hour of fire or smoke outside to coming to inside. So the way in which the code is written is protect life first, then property. And so we had a loss of life that was mostly related to those who did not want to leave when they were requested to be evacuated. And then we had those, the firefighters as well. We had those casualties as well. The code is not written right now to protect property as well. And I think that that is probably going to need to change as well. Because the amount of loss and the scale of loss is just crazy, right? So you had a collection of buildings from you had a collection of buildings from sort of, multiple years that were not up to code. So what was happening with those buildings? You had very high fire condition with embers going into fireplaces. Those embers were going into touching eaves that were exposed that are made of wood because we do wood construction. They were going into the attic space either through eaves or through other windows where we end up with insulation and other elements that are flammable. These embers get in, fire starts spreading in and then out. And now you take a high fire condition, same thing starts to happen. So now how do we prevent that from happening? We prevent that from happening by creating what's called resilient design. So if you're going to end up with eaves, those eaves need to be protected. We have to have airtight construction. So one idea is don't do any eaves. Don't have fireplaces. We have electrical fireplaces, but don't have anything that will allow entry. Vents that we need to be closed off and or protected so that they still allow for air to come out but don't allow for the embers to go in. We need eave construction to be done in such a manner that you end up with, fire resistive construction. So if you end up with a eave that is airtight, which is made with standing seam metal roof or with other such fire resistant material, you will end up with an airtight, and it will not allow for fire to get into the building. It will resist fire. You want your windows and your building envelope, which is your walls and your roofs, to have materials that are fire resistant materials. And so you want your windows to be tempered glass. They don't blow with the smoke and the air pressure that's generating between the inside and the outside as a result of all that heat and all that wind. You want to have, you want to make sure that not only as the windows are closed, that they're airtight and they're tempered glass, but you also want to make, and they're fire resistant glass. But you all, and fire resistant glass is different from tempered glass. It's even more. But you also want to make sure that you've got your building envelope is got made of fire resistive elements like brick and concrete and metal and CMU block walls and stone, which will not catch fire. They are natural suppressants of fire. You want to make sure that that any fire that was going close to here, that you've got a certain amount of space around the main structure that does not have the kind of vegetation and elements that can cause fire. You want the perimeter of your house and the boundaries of your house to be made of elements like concrete or CMU block walls that will prevent from one property being burning to stop, stop those perimeters. So no wood fences. So those are the elements that are going to make for fire resilient design. And will the codes bring them into play? I think so, absolutely. If we don't learn from that, how else do we learn, right? There was some interesting folks who had done some experimental stuff. There was one that I read where this gentleman in his house, he had installed fire, sort of irrigation sprinklers. He had attached them to his hose, and he knew this was an issue, and he had taken the high powered sprinklers, irrigation sprinklers that are used in golf courses, and he had actually installed them on his roof. And before he left and evacuated, he connected them. He already had that system in place. He connected them with a hose and switched the water on. And so that started to create moisture. And it not only protected his house, but it also protected the houses of all the other folks as well, because the embers, the moment they landed, were closed off. So wind patterns also affected it. But do you see how you can create resilient design against fire? And of course, there are multiple things as well for us to think through as we sort of specify. And, you have to have the right kind of contractor making sure that it is airtight. We need regular maintenance of buildings. And then we need to make sure that if we're living in high fire hazard zones, like the mountains, like the hills, that we don't have a choice, but we have an inspection and maintenance of our structures so that they can't they can't lit up like a matchstick. So does that answer your question? Okay. Well, it's close to 3 o'clock right now. Can I answer some sort of last questions, if you will?
I guess like one question that I have is like, would how how is it possible for the construction industry to like rebuild this quickly? Like if you have like thousands of structures that wouldn't be normally like built or like needed to be built in like a normal construction year, can the infrastructure that we have in terms of like private contractors and all that, can that sustain build like buildings that are going to happen now, or are costs going to go up 2-3 times because of this?
Right. Excellent question. All to be seen. However, I can tell you what my opinion is, and my opinion could be wrong as well. It's all speculation at this point, right? So let's talk about timing first. We have a lot of toxins that are generated as a result of all of the burning. Why? Because building materials that in the and the materials that we burn that we build with, when heated up, release a lot of toxins and heavy metals. So at the moment, we have a lot of that in the ash and in the soil and sort of all over. And so the Environmental Protection Agency, which is a part of the federal government, comes in when a situation like this happens to then remove all that hazardous waste. Because that hazardous waste is actually really terrible for any life. So they're going to take they had said that they may take anything from, I don't know, like 3 months or a bit more for um, for the Environmental Protection Agency to remove that. Then you get next comes in the Army Corps of Engineers, and they're again a federal agency. What they do is they remove all of the debris. So first you have the hazardous removal, the EPA does. Then you have the Army Corps of Engineers. The Army Corps of Engineers will then remove the debris, and they will also remove a minimum of 6 inches of soil, because the soil has received, that waste all falls down, it falls into the soil. So they'll remove 6 inches of it. In order for them to do that, they require a right of entry from every they require a right of entry from every property owner, and they will do this for free. That's what our government, that's why we pay taxes. That's what government agencies are supposed to do. That's why we have these departments, and that's why we pay taxes. So the Army Corps of Engineer would do that, and they need a right of entry form signed by every developer, by every property owner. Otherwise, they can't do that. Once that is done, now you can start the building process. For that, you need the architects and engineers to come together to be able to design and submit the drawings for the rebuilding process to the agencies, which is the city. And the city needs to look at that for code compliance, not only current code compliance, but what should the new buildings be designed to, what minimum code standards. That needs to happen as well. And so there's time required for the architects and engineers to be able to design and produce the construction documents and submit it for plan check. And the city then needs to review it for compliance for code, fire, and life safety again. Now, once you've received an approval, you start construction process. Now, how can we make construction simpler? There's an economies of scale model, and I've been speaking to a few contractors about this. And so the idea there is, what if you were 10 houses on the same side of the street? And you got those 10 houses and you did all their soils is going to be fairly similar to one another. You can have similar concrete pours. There is, you can sort of like try and have the same contractor be able to build those 10 houses. So you will need a certain amount of capacity. That is one model, not the only model. Now, that is if the city says you have to build like for like. Unfortunately, insurance companies will come in and they will say, well, if you want, we owe you what you were insured for, what you paid us for, which is what you was insured, which is what was built. So get the blueprints from the city, bring them out, let's bring them up to code, and then let's build them. And they will pay for like, and with like for like plus 10% improvements. Those who want to do more than 10% improvement, the process might look a little bit different. So that's all like process question. Logistics question is, how can we do that? Now, there's another way. That is, some property owners may say, and it's all to be seen, well, we don't know how long this process is going to take. We're just going to go buy, take our insurance money and buy a house somewhere else. And in that case, we'll just build differently or we sell. In that case, they're not building like for like. There's the possibility of sort of using modular construction and prefab construction to be able to build differently, resiliently, faster. Fabrication happens off site, foundations get poured on site, but the assembly happens faster and quicker. Now, how many of those are going to happen? We don't know. We don't even know if people are ready to even build. I think people are still grieving. They're still figuring out what their insurance will give them, right? There are some who are, going to build faster, or they've already figured it out. They've got their architect, they've got their contractor, they started the design process, they started the process. They're already moving on. That's their sort of the action that they can take. There are others who don't know. They're still figuring out with their insurance people as well. But we've lost not only homes, we've lost schools. Like we are at the moment moving an independent K through 8 school because even though their campus didn't completely burn, a part of their campus burned, they can't access the campus because it can't go there. It's not safe for the kids or the adults, for anyone. So we're actually assisting them and moving them into an office building right now. So you've got the whole community of schools is gone. Churches have been lost. Businesses, office buildings have been lost. Apartment buildings have been lost. And so how do you solve for this, right? How do you solve for the cleanup? How do you solve for the logistics? So in some ways, you know, is it, the process will reveal itself. This is a little bit unprecedented. You can learn from what happened at Paradise a few years ago. You can learn from what has happened in Maui with the fires that happened 2 years ago in 2023. You can learn from the Australian fires of 2019 and see how they, what eventually happened there, to try and, see and speculate what could happen here. Now, Altadena is a completely different sort of diverse community. And it's a different kind of community than maybe the Palisades community might be, right? So how does that impact them? There were, there were senior homes and apartments for, sort of assisted living facilities that were lost. So do we have the capacity? I think we have the capacity from a construction point of view. Do we have the capacity from an agency point of view to permit everything? I'm not sure about that. Do we have enough architects to be able to design? I think so. Will we have material shortage? I can foresee that we may have a local demand and supply issue. I can foresee that, but it's all speculation. Um, I think that, so I'm a part of a nonprofit organization called Architecture for Communities Los Angeles. And we're a sister organization of the American Institute of Architects, which is an industry, architecture organization. What we've done is we've come together to create a wildfire task force. And our goal is to also be at the table with the the mayor of Los Angeles, Karen Bass. She has appointed a chief rebuilding officer. So, our goal is to sort of meet with him and, be at the table in terms of providing strategic thinking, knowledge, so that, we are able to design and plan for the logistics of building appropriately for the different conditions, for the different kinds of things. There are individual homes, there are apartments, there are houses, there are schools, there are businesses, there are hospitals. There is so much that is lost, right? And then there is infrastructure work. And so I think it's going to reveal itself. I hope the process is not going to be completely organic and completely chaotic. Um, if it's organized chaos, at least we know, we'll all sort of be much more thankful. And that answer will sort of come from both public and private strategy and planning and organizational thinking to come together. And it'll reveal itself. I don't have an answer right now. I think we're all figuring it out.
What about from a zoning standpoint? Do you think anything will change in terms of if families in a certain area want to sell their properties and leave? Do you think the city is considering upzoning in terms of having more apartment buildings to solve like housing shortage in that way? Or do you think it's mostly going to stay single family for at least for the Palisades, I'm thinking?
Yeah, so, good question. Again, we need to be at the table to understand that. There might be families who may decide to leave, right? They might say it's not worth, and then developers or greedy developers, greedy contractors, greedy whoever people might come in and try and seize those properties and do whatever they want to. Um, I can give you my opinion on this. My opinion on something like this is that I hope that we don't end up taking, even though this has been such a terrible, terrible loss, um, you know, if rebuild doesn't happen in a planned, conscientious, sustainable manner, we could end up with a worst case scenario where we'd sort of end up with uh, a sort of a stamped model of things, which is a repetition, if you will, in a way that may not have sort of the diversity of structure and design that we would sort of see that Palisades was rich for. Communities made of very, very different kinds of buildings and styles, and they that's what makes them interesting. Or what brings it all together is our streetscape, our trees, our palm trees that lost, that sort of like were like torches that unfortunately exacerbated the whole issue as well. And so, there's a whole street tree, landscape, urbanism that sort of needs to be looked at from a fire and life safety point of view. But at the same time, we want greenery, because without those greenery, without having trees, you end up with, heat island effects. Tree-lined streets provide not only shade, they provide microcosm for, multiple types of living beings. They contribute to our experience as we walk from one house to the other, or take our dogs for a walk, or walk from, to our neighbor's house, if you will, across the street, or whatever it might be. I think we don't know. Is there a collective effort? I really want to be on top of that. I want to understand it. That's why, we created that wildfire task force through our nonprofit that I volunteer for, so that we can be at the table to be able to understand, you know, how, how things are changing from an economical standpoint, and sort of from a design standpoint, from a sustainability standpoint, from a financial and fiscal standpoint, because everything sort of comes together, right? And so we want to make sure that we're at the table to, that at the end of the day, this calamity that has, and this devastation, apocalyptic devastation that has happened, that in order to survive that and to move forward with that, and if we were to take that next step and say we were rebuilding, let's do it properly, whether that's zoning or not zoning. Palisades has some soils issues associated with it. And so does it make sense to have more people there with multifamily housing? I'm not sure. I think we need to think through that a little bit from a macro scale perspective. The west side, there is the city of Los Angeles already has a West Side community plan update coming up, where they are, through the housing element, that is dual, and this, they have already identified properties that are to be upzoned to have more density. The cities. So, do we think that that might get updated as a result of what has happened? Uh, Maybe, which is the right places to add more density. We need to think through that. There is a much larger exercise that needs to happen. I'm not sure if the government can do it completely. I think it may be better for, them to release an RFP and create a body of strategic thinkers that would come together to evaluate what is the best way for us to move forward, especially if you have large swaths of properties or multiple properties that are available because multiple people decide not to build. Then we have a problem. I mean, it would be much nicer if there's a way we can keep the community together to rebuild and rebuild resiliently. That would be awesome. But not everybody had insurance, so I think that the problem and defining the problem, if we go back to our design thinking process, is going to reveal itself because things are unfolding, right? Once we understand and define the problem, and understand the scale of it, then we can figure out what's the way to address it. At the moment, I think it's a bit unknown.
Definitely. Thank you for that answer. That's very interesting.
Yeah, that's where we are. Kai, are you still there?
Yeah.
Okay. Um, can I help answer any other thing before I um go back to my work?
Like when you like make sketches to like design a floor plan,
Yeah.
uh, how do you like do it, and like what goes through your mind as you do it?
Sure. Great question. Very, very, very good question. So let's go back and take a look and see if I had any sketches of plans. So we definitely, we collect all of the data, and, you're seeing a lot of finished drawings and products. So it starts from first gathering information and facts, prior putting them in an order of priority of needs and wants, and then understanding and defining goals that we want to achieve at the end from a finished product. That goals and those priorities in the buckets of needs versus wants will help guide you every process of the design way. So that's what's happening in the back of my head, right? What is the armature and the rules? Now I start with the ergonomics and not just what the building code is saying. So if I am designing a room, if I'm designing a closet in that room, if I need a bed in that room, if I need a desk in that room, if I need a grand piano or for that matter, if I want a table in which I want a light table because, Kai, I need a large space to be able to have a cutting board and my paper so that, I have a space where I can build all my models, just like you've been building them, right? Then I will design my room accordingly with much more horizontal surfaces where I can work at, a place where my computer is, okay, it's probably where my two screens are, a place where I can sketch, a place where I can cut, a place where I can put my tools. If you're doing work with paper, you want to be able to work in. So, what's going through my head is all of the processes of my users' needs, and I'm sketching and thinking of sequence and thinking about the human body and thinking about ergonomics, which is how a human being behaves in a space and with um, the table and the chair. What color should it be? What kind of design should it be? Because what kind of a person are they? Have they shared with me what they like and what they don't like? And so as I'm sketching, all those factors come together into different ideas. Sometimes, if I'm lost, I look at case studies and I look at what other people did. How did they respond to that particular issue, right? And I'm sketching. And then, I'll sketch and say this is option one. And then option one will result in, oh, maybe I could do it another way, option two. So I sketch that. And then I do an option three. And sometimes I exhaust all my possibilities and I look at them and I say, okay, which one is is closest to meeting the needs and the wants and the goals? And so let's say I like shortlist them down to three. And then I start to develop what do they look like from a three-dimensional standpoint. And sometimes I'm sketching in 3D and I'm sketching by hand in 2D, both plan sections, elevations, and 3D. 3D. Sometimes I'm sort of looking at images that are inspiring me. Sometimes the context that I'm in, if I'm next to the ocean versus the wind versus on top of, sometimes like if I'm on top of the hill and I see the beautiful blue ocean, then, I want to capitalize on that. It makes sense for me to have as much expanse of glass as possible so that I am, I am and capitalizing on that beautiful view. It doesn't make sense to have solid wall there, right? So what's going through my head as I'm sketching is all of the data I've collected with my goal and my priorities of my needs and wants and the imagination that I have to be able to come together to solve the problem through that design thinking process. And at some point, I take that and I put that into a software and I start to do this with actual dimensions once I've done these sketches. And sometimes I have my staff try and, I guide them in terms of how I've thought about it. A door is usually 3 feet, you know, that's how big a door is. You already know these as you sort of practice architecture. Your closet needs to be 24 inches deep. You know that your kit of parts, like your table is, either 3 feet wide or 2 feet 6 inches wide, and it's either 5 feet or 6 feet. If I want to go smaller than that, does it make sense? What am I doing it for? Do I even want, does my user even want to have their workspace, their study space in their bedroom, or they prefer to actually work in a completely different space? Should I, if we have lack of space, then should we create different zones within the room? Are they introvert? Are they extrovert? And then I'm thinking through multiple things, right? And sketching. And then I put that in and I start to give it form in 2D, but I also start to do it in a model, a software called SketchUp or a software called Rhino. And then I start to apply materials and colors to it based on who it is. Is it Zen? Is it bright? Is it just it's natural elements? Like, am I designing a school or, for elementary kids? What is that going to be like? Do I want to celebrate the work that the kids are going to create and give them a blank, universal, beautiful, natural palette? Or am I going to create a vibrant and, environment with lots of colors in it? I don't know. It depends upon the vision and the goal we've established with the users as well. Again, goes back to my, and then I'm playing with Rhino, I'm playing with SketchUp, I'm rendering, I'm sketching, and that's sort of that iterative process, if you will. Um, does that answer the question?
Yeah, thank you.
Of course, the more you sketch, the more you observe, you go out into the world and you travel, the more you see, the more you learn, the more you read, the more it influences you. Um, Poems, the natural, you just don't know what will give you the inspiration to create form and space that will help be purposeful and address efficiency and function. So just be curious and keep traveling and learning and keep sketching and keep observing. There's a lot to learn.
Okay, thank
Great.
you. Bye.
Of course. All the best to both of you. Happy to help you answer any questions and keep in touch.
Okay,
All right.
thank you.
Thank you so much.
Of course.
Really appreciate it.
Bye.
Yeah. Bye, Eric.
Bye bye.